Hello everyone, I'm Hua from Baidu. My colleague Jing and I will introduce our efforts on building NLP benchmarks from an industry perspective. Here is our outline. I will talk about the first two parts of this talk, and Jing will take the last two. In the introduction, I will first introduce the great progress on the NLP benchmarks that have been made in our community, and then put forward the challenges in real-world applications. In recent years, the researchers from academia created large-scale datasets, many in a crowdsourcing way, which greatly promoted the NLP research. One example is Squad. It greatly accelerated the development of machine reading comprehension technology. Now, these systems outperformed humans on this specific dataset. With such great success, more and more datasets were created. As we see, most of previous datasets such as pantry banks are focusing on some basic problems such as parsing and semantic labeling. With the success of deep learning methods, more and more application-related datasets were created. For example, for dialogue systems, question answering, and translation. Besides the one single dataset for one task, recently shared tasks or benchmarks are collecting different kinds of datasets to evaluate the generalization capabilities of models. For example, the benchmarks GLUE and SuperGLUE are proposed to test the general understanding capabilities of models. For some specific tasks such as question answering, MIQA Workshop organized a shared task to evaluate the generalization capabilities of the models. These models are usually trained on existing multiple datasets and then tested on out-of-domain datasets. Despite the previous success of these datasets, they were created in a crowdsourcing way. They usually present different distributions and different challenges for those in real-world applications. If we can obtain datasets from real-world applications, these datasets contain natural occurring linguistic phenomena, which present real distributions for applications. In a real-world application, we need to consider the robustness of the models and consider if these models can be deployed in different tasks and in different domains. And besides in text applications, sometimes we also need to consider if these models can be also suitable for multimodal scenarios. Furthermore, current models usually suffer from knowledge hallucination problems. It is crucial to integrate knowledge into the models to ensure the knowledge accuracy. In order to overcome these challenges in real-world settings, Baidu NLP has made some efforts to build some datasets. Here is the whole picture of our open datasets. We have built 14 datasets for real-world settings in information extraction, sentiment analysis, machine translation, dialogue, and question answering. For information extraction, we focused on relation extraction and event extraction. For sentiment analysis, we focused on trustworthy sentiment analysis and multimodal sentiment analysis. For machine translation, we mainly addressed the two challenges. One is for simultaneous translation, the other is for low-resource translation. For dialogue, we focused on incorporating knowledge into dialogues to make the conversation more informative, coherent, and engaging. For question answering, we focused on addressing the robustness problem of the models. So, In the second part of this talk, I will take question answering, dialogue, and simultaneous translation as examples to introduce our efforts to target the challenges in real-world applications. First, let me introduce our efforts in building question answering benchmarks in real-world setting. For this task, we built the Do-Reader dataset. This is a Chinese machine reading comprehension dataset. Both the questions and the documents are from Baidu search. Before I go into the details of Do-Reader, I will first introduce machine reading comprehension task. Given a passage and a question, the machine should extract the answer to the question from the corresponding reading passage. This kind of task is first addressed in Squad, which is built by Stanford University. In Squad, questions are created in a crowdsourcing way, focused on factoid questions. The answer is from one single passage. But in real applications, besides the factoid questions, there are also many other questions, and the answers are usually from multi-documents. In order to address these challenges in real-world applications, we created Do-Reader, which is a Chinese MRC dataset. Both the questions and the answers are from Baidu search. In Do-Reader, we classify the questions into two kinds: factor-related questions and opinion-related questions. And each type, the questions can be further classified into three types according to the answers. If the answers is one or more entities, it can be classified as an entity question. If the answer contains a description of a text, it can be classified as a description question, and so on. The answers of the questions can be extracted from more than one document. One question can have more than one answer. Now, Do-Reader is the largest Chinese MRC dataset so far. The dataset can be downloaded from GitHub, and based on it, we built 3 more datasets to focus on different challenges. Since yes-no questions are very difficult for models, so we created a new dataset to focus on this type of MRC problems. In order to improve the robustness of models, we created the 2 more datasets to address this problem. Based on Do-Reader, we also organized the shell tasks since 2018. On this dataset, the performance of the models have not outperformed humans yet. This shows that this dataset for real applications is more difficult for models. The second dataset I will introduce is for dialogue. In an open domain conversation, it is very important for chatbots to be equipped with knowledge and proactively chat with humans in order to avoid safe responses. So, we built a dialogue dataset Do-Cover, which mimics humans to use knowledge for chatting and to proactively lead the conversation. The goal is to enable chatbots to conduct knowledge-grounded conversation. In this task, the chatbot proactively leads the conversation to complete the given goal with the related knowledge. Here, we use the knowledge graph as background information. First, the bot starts the conversation with an open sentence. For example, by asking the user if he or she wants to watch films, and then use the entities and its faces to guide the conversation to recommend a film. Based on this film, we talk about this is detailed information, for example, the comments posted by the audience. Finally, based on one facet of the target film, to lead the conversation to discuss the actors of the film. In this dataset, we hope the models can use knowledge to proactively lead the conversation, and then can chat with humans deeply into one specific topic. The dataset can be downloaded from GitHub, and based on it, we also organized a shared task since 2019, and many teams from both academia and industry participated, and greatly improved the performance of the models. The third dataset, I will introduce this for simultaneous translation. Since it contains speech data and text data, it is a multimodal dataset. As we know, there are three main challenges for simultaneous translation. The first challenge is we lack speech-to-text training data. The second challenge is how to make a balance of translation quality and latency. The third challenge is that there is no standard evaluation metrics for simultaneous translation. In order to tackle with such challenges, we create a dataset for Chinese-English simultaneous translation. We hope more models can be trained on this dataset to address these challenges. The dataset was collected from Chinese talks similar to TED. The domains contain technology, economy, culture, art, and so on. The dataset contains about 6 to 8 hours of speech. Here's a comparison of BSTC and other datasets. As we see, BSTC dataset is the largest Chinese to English speech-to-text corpus so far. Each sample of BSTC content is Chinese audio, the ASI result, the transcription, and its English translation. Last year, we held the first workshop on simultaneous translation at ACO, and the second workshop this year at NACO. On these workshops, we also organized the shared task for simultaneous translation based on BSTC. In this shared task, we evaluate the translation quality with blue and the latency with the average lagging. We also proposed one new evaluation method to rank the translation systems. Now, more and more researchers are working on simultaneous translation. Although we have created 14 datasets for real-world applications, it's still not enough to cover all of the NLP tasks. So, we need to collaborate with the researchers in the NLP communities to contribute more and more datasets. So, we launched a new project named Luger to address the more problems in real-world applications. My colleague Jing will describe this project in more details.
Hello everyone, this is Jing from Baidu. Thanks for Hua's presentation on the first part of this talk. And I will continue the second part. In the second part of this talk, I will talk about Look, which is an open source project of Chinese NLP benchmarks. Specifically, I will talk about that how we collect and create new benchmarks to address the issues and challenges in the real-world settings, including robustness in question matching, faithfulness in text generation, the multi-task and multi-domain in sentiment analysis. First, let me introduce the background of the open source project Look. Look is an open source project of Chinese NLP benchmarks. It was jointly launched by Baidu, CCF, that refers to China Computer Federation, and CIPSC, refers to Chinese Information Processing Society of China in August 2020. The aim of LOOC is collecting and creating new benchmarks to address the challenges of natural language processing, such as robustness, faithfulness, and generalization, etc. Besides, LOOC aims to cover rich types of natural language processing tasks, including language understanding, language generation, and multimodal tasks. Currently, LOOC already have many great contributors from different organizations, as shown in this slide. Since the launch of LOOC, currently LOOC already covers 10 tasks of natural language processing and 36 datasets. To help the students, developers, and researchers to better utilize these datasets, we provide unified data formats and evaluation scripts for each task. Besides, we also provide baseline codes for each task and help the students and developers to easily train the model. Here is a list of the 10 tasks in LOOC, including dialogue, simultaneous translation, machine reading comprehension, question matching, information extraction, sentiment analysis, low-resource machine translation, semantic parser, entity linking, and text generation. Next, I will talk about the benchmarks for 3 tasks and the corresponding challenges, including the robustness in question matching, the factual faithfulness in text generation, and multitask, multi-domain in sentiment analysis. First, let's start with the task of question matching. The task of question matching is identifying the question pairs that have the same intent. We can train the neural models of question matching from the training data. However, the researchers find that the neural models may just learn the shortcuts from the existing training set and suffer from the robustness issues in the real-world settings. As shown in the bottom figure, the 2 questions are similar in terms of lexical overlap. However, their meaning and intent are different. If a neural model is not robust, it will not capture the subtle difference between the 2 questions and then make wrong predictions. To help address the robustness issue of question matching, we collect and create a new benchmark for the robustness evaluation. We have 3 datasets in this benchmark. We use LC-QMC and BQ corpus for training and DoQM for testing. Here, LC-QMC contains the general domain questions that is collected from Baidu Zhidao, and BQ corpus mainly contains bank questions. And DoQM is a testing-only set for robustness evaluation. Let me introduce DoQM a little bit. DoQM is a Chinese dataset of linguistically perturbated natural questions for robustness evaluation of question matching. As we can see in the table, it contains adversarial examples with fine-grained linguistic perturbation, including word and phrase, named entity, synonym, and autonomy, negation, and temporal, and some syntactic structure. Different from other adversarial datasets, all the questions in DoQM are natural questions from Baidu search instead of the altered question. Since we consider that the improvements on the unnatural adversarial examples may not help the true improvement on the true natural questions from real-world applications. Next, I will talk about the benchmarks for the faithfulness in text generation. Text generation is generating natural language description based on the input data, including various tasks such as data-to-text, summarization generation, and question generation. Data-to-text is generating natural language description based on the structured data. And summarization generation is generating short summarization based on long documents. Question generation is generating the questions for a given document. As we know that fluency is one of the most important aspects to measure the generation quality. However, we consider that in the real-world setting, the factual faithfulness is even more important. As shown in this example, the first prediction is fluent comparing to the reference. However, the fact in this prediction is wrong. The second prediction gives the correct fact, even if it's not similar to the reference. So to better evaluate the factual faithfulness in text generation, we collect 3 datasets, including adversarial text generation for data-to-text and LCSTS for summarization generation, and DoReader for question generation. In the evaluation metrics, we use both natural language inference and manual evaluation for faithfulness evaluation. Last, I will talk about the benchmarks for multitask, multi-domain, and multi-model in sentiment analysis. The task of sentiment analysis is identifying the opinion, sentiment, affect, emotion, and mode expressed in the text, video, and audio. Here is an example. We expect that the machine can extract that John has a positive opinion on the touch screen of the iPhone from the text. And from this definition, from the definition of the task, we can see that sentiment analysis actually involves multitask, multi-domain, and multi-module challenges. By multitask, we mean that there are multiple subtasks, including sentence-level sentiment classification, aspect-level sentiment classification, and opinion extraction on specific aspect. By multi-domain, we mean that there might be multiple domain, like a book review and full review. By multi-model, we mean that we should analyze sentiment on text, audio, and video. To better promote the unified modeling of multitask, multi-domain, and multi-model sentiment analysis, in Look, we collect 8 datasets for 4 tasks on 10 domains and 2 modules. Next, let's see the impact of Look in the Chinese NLP community. When we launch Look, there are only 7 tasks and 22 datasets. From the left figure, we can see that we have more tasks and datasets in Look now. And the right figure shows the usage of Look. Currently, it has more than 30,000 downloads and more than 20,000 submissions. In the future, we would like to invite more authors to join us and build Look together. In the next 3 years, we plan to collect and build 100 Chinese NLP datasets for 20 tasks, covering the tasks of knowledge graph, natural language understanding, natural language generation, application tasks, and multimodal tasks. Finally, let's come to the conclusions and future work. In this talk, we present our efforts to deal with real-world challenges of natural language processing by creating the new benchmarks for dialogues, translation, and question answering. We also present our effort to work together with the whole community to create the open source project Look to address the more challenging issues such as robustness and factual faithfulness. In the future, we plan to create and release more benchmarks from the real-world applications and share it with the researchers in the academia. And we also consider that multimodal is quite important area, and we will plan to create more data sets on multimodal tasks. Thanks. That's all for this talk. Please visit look.ai if you are interested in learning more about the open source project Look. Thanks.